Hello, everyone. I'll talk about electromagnetic radiations today for your course, IGCSE and GCSE. Now, these are electromagnetic radiations. Electro are basically waves of electromagnetic nature. So these waves, they include radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. So these are the different types of electromagnetic radiations that we have. So we have blocked them. There are so many in numbers that we have blocked them according to their frequencies and wavelength. Remember the wave equation. So V is equal to F lambda. This wave equation, as you can see, involves frequency and wavelength. So these electromagnetic radiations are basically bent together according to their frequency and wavelength range. Here you can see the frequency ranges. So radio waves has a particular range, and then you can see the microwave has a particular range. You can see the infrared and all of them. They have certain ranges. Now, there are some common properties on the basis of for all of them. They are separate in one way in their frequency and in their wavelength, but they have some common properties. And we need to know those common properties. So for your course, so common properties for, I'm just saying EM, electromagnetic radiations or waves, whatever you would like to call it. So what are the common properties? I mean, all of them, as I said, all of them are transfer waves. They're not longitudinal, they're transfer waves. They are all transfer waves. Secondly, they all can travel through vacuum. So they don't need any medium. Like they don't need water to move through. They don't need a string to move through, a spring to move through, or air particle like sound waves. They can travel through vacuum. So they all can travel through vacuum. And the third property is they all travel with the same speed in vacuum. They have same speed in space or vacuum, which is something you got to know. And that is around, if I write it down, it's going to be 3 into 10 to the power 8 meters per second. This is the thing that you need to remember. They all carry energy. They are waves after all. So if you remember the main definition of the energy, they carry energy. That's what they do. So they all carry energy. And which one of these waves, these bands of electromagnetic radiations like gamma, X-ray, ultraviolet, carry the most energy? And higher the frequency, higher the energy they carry. That's the rule. Higher the frequency, higher energy they carry. So it means that gamma radiation, it has a look at the frequency. The frequency, you know, is measured in hertz. H-E-R-T, hertz. Hz as a symbol. So you can see that it's increasing with 10 to the powers. So the frequency, the gamma has the highest frequency. It's increasing towards the right. It's 10 to the power 20 for the gamma. So it's very high frequency. It means that it carries the most energy, and that's why it's dangerous. So another thing that you must be aware of, if you look at the equation, wave equation, like the one I showed, V is equal to F lambda. Since the speed is same for all of them in a space, we usually represent the C for the electromagnetic radiation, for their constant, because of their constant speed, we represent it with C. Although we are aware of the fact that this C is basically 3 into 10 to the power 8. If I rearrange it, you can see that frequency would then be the inverse of the wavelength. What is lambda? Lambda is the wavelength. F is the frequency. So the wavelength, if you look at the wave, this is the wave we usually represent with. So if you stretch it more, if this whole length is bigger, that's higher wavelength. But higher wavelength actually means lower frequency. So this has a higher wavelength, but lower frequency. Then this one, lower wavelength, higher frequency. So they have inverse relationship. It means that if you look at this same frequency arrangement, how would you arrange the wavelength? It's gonna go the opposite. So the wavelength is lowest for the gamma and then highest for the radio wave. So wavelength increases. How? It increases that. So lowest wavelength, lambda means wavelength, and highest wavelength. So that's what we need to know about the electromagnetic radiation. Further, you must know the examiner sometimes would give you questions like they would miss out some of the bands and would ask you to actually fill in the gap. So something you need to know how you arrange or you fill the gaps of this electromagnetic radiation. So like the longest wavelength is radio, then comes microwaves, then comes infrared, then comes visible light, then comes UV light, then it's the X-rays, and finally gamma radiations. So these are the blocks you need to remember. But don't forget the fact that even these radiations are not just single frequency, they have a range of frequencies. And again, the wavelength, as you can see here, it's the radio is from the 10 to the power 4 all the way to 10 to the power 8. So they have quite a range of frequencies. The range of frequencies is also sometimes called spectrum. So this is also called electromagnetic spectrum because there are so many wavelengths and frequencies are there. So this entire thing is also called EM spectrum. Next, we need to talk about the uses of these radiations and what are the sources